In this video, we will talk about what random variables and probability density functions are. So in chapter 2, we looked at some probability questions, and the probabilities that we looked at involved, they were with equally likely outcomes. So equally likely outcomes. And in chapter 3, we considered probability in more detail by looking at probability, I'm just going to abbreviate, measures. And we looked at more general probability techniques. So we looked at things like tree diagrams and conditional probabilities and Bernoulli trials. So in chapter 4, what we're going to do is we're going to look at probabilities, but with what we will call random variables. And one of the main uses for this is that this is a bridge between the stuff that we've talked about in chapters 2 and 3 and statistics. Alrighty. So let's look at an example. So the example says that you bet $2 to play a game in which you roll a die. If you roll a 6, you win $5. If you roll an odd number, you win $1. And if you roll 2 or 4, you win nothing. So in this scenario, let's just make a table in which I'll consider the roll and then whether we have a gain or a loss, and then what the probability was of that happening. Alrighty, so when we roll a die, we could either roll a 1, a 2, a 3, a 4, let's zoom it out a little bit, a 5, or a 6. And for each of those rolls, we have a 1 out of 6 chance, so 1 out of 6 probability here. Let's write that a little bit better. 1 out of 6. This is 1 out of 6. 1 over 6, 1 over 6, 1 over 6, and 1 over 6. So in the case where we roll a 6, it says that we win $5. So we win $5. But remember that we had to pay $2 to play the game. So, but we still had to pay the $2 to play, which means overall we would gain 3. I'm just going to write 3, although it's $3. So if we use that same idea, when we roll a 1 now, so if we roll a 1, this is an odd number, and with an odd number we win $1. Win $1, but we still pay $2 to play, but we pay $2. And that would mean we lose overall, we lose $1. So I'm going to write -1. That minus is indicating that we're losing $1. All right, let's do one more of these slowly. Actually, before I move on to 2, it tells us that for any odd number, we're going to win $1, which means for 3 and 5, we can knock those out as well. Here, it's going to be -1. Here, it's going to be -1 for our loss because we're going to win $1, but pay $2 for each of those as well. So now let's do rolling a 2 or a 4. In that situation, we win nothing. So if we roll a 2, we win nothing. But we still pay the $2 that it takes to play this game, so I would write a -2 for our overall loss. Same thing when we roll a 4, it's a -2 overall for our loss. Okay, so we can summarize the things that we're observing in this table with a more concise table in which we just list the outcome as well as the probability next to it. Okay, so there are three overall types of outcomes depending on the gain or the loss that I see. I'm going to call one of these a big win. So the big win is if we win $3. Or we could have a small loss, which is if we lose $1. Or a bigger loss. So I'm just going to call that a big loss of $2. Those are the three overall sort of outcomes depending on how much we gain or lose. So for a big win, we saw the probability is 1/6. For a small loss, well, that happened with three of these rolls. If I rolled a 1, a 3, or a 5, so I add up their probabilities. So this would be 1/6 plus 1/6 plus 1/6. If we add those up, this is 3/6, which simplifies to 1/2. Okay, and then for a big loss, there were two rolls that gave us that. If I rolled a 2 or a 4, so I add their probabilities. So I add 1/6 plus 1/6, which is 2/6. And if I simplify that, this is 1/3. So I'm just going to highlight these simplified probabilities. 1/6, we had 1/2, and we had 1/3. Alrighty. So this is an example of a random variable. In that it assigns a number to each outcome of a sample space, which I will call S. So in this case, we can think of these outcomes in this example as being the big win, the small loss, and the big loss. We got those three outcomes. And then the numbers that are being assigned to them are these values, the overall gain or their loss. So let's introduce next some notation to talk about random variables. So we usually use uppercase or capital letters to refer to random variables. So let's let X denote our random variable. And let's state a little bit more explicitly now what our random variable capital X means in our example. So in our example, X is the money gained from, let's write that F better, from playing that game once. So this is in our example what our random variable represents. So then our random variable X could equal a few different things. We saw that it could equal 3, it could equal -1 if we had a loss of $1, or it could be equal to -2 if we had a loss of $2. So collectively, these numbers are called the values of our random variable. So our random variable in this example could take on 3 values. So we are ready for another key definition now. So what's called the probability density function. So the probability density function, or sometimes we will abbreviate this by writing PDF, probability density function, we'll call that PDF. The PDF of a random variable X assigns probabilities to each value of that random variable. So let's end by doing a quick example where we find the probability density function for the random variable X in our previous example. So we already listed the probabilities of each value in that table, but I just want to write this a little bit more explicitly. So first I want to note something. When a question asks me to find the probability density function, this simply means to write the probability of each outcome. So in this case, there are three different values that we could have, 3, -1, or -2. So we write down the probability of each one of them occurring. So our notation for that is I will write the probability that my random variable x equals 3, and I will say what that probability is. So, well, what does this notation even mean? When we're saying that x equals 3, that means that we are gaining $3 because x in our example represents the money that was gained from playing the game once. So in fact, just so that this example, this notation, when we write x as our random variable in the previous example, just so it's a little bit more clear, let me highlight that up above as well, because we wrote down what x was from our example. It was the money that we gained from playing this game once. Alrighty, so when I write probability, parentheses x equals 3, that just means what's the probability that we gained $3? And we saw that was 1/6 from our table. So I got to do the same thing for each of the outcomes. So I need the probability that x equals -1 and the probability that x equals -2. So when x is -1, that means we lose $1. We saw that probability was 3/6, which simplifies to 1/2. And then the probability that x was -2, we saw was 2/6. And that simplified to 1/3. All right, so one thing to notice about these values is these fractions, all these probabilities, they sum to 1, which is great because the probabilities of all of the different outcomes should sum to 1. And that is the answer to our question. So again, just to reiterate, when a question asks for a probability density function, it simply means that we should write the probability of each outcome. So in terms of our goals for this section, now we finished our first goal. We've defined what random variables and probability density functions are. So for the next several videos, we're going to be looking at some examples to get more comfortable with each of these things.